All right, today during this session, we're going to be talking a little bit about brain development in the very early years, and this is I think is a pretty interesting thing, and I hope that you will learn something. And I will start this again because this is stupid. All right, so right now we're going to be talking about early brain development, and I think that brain development is actually pretty great. It just fascinates me every time I read something about it, or I learn something, or relearn something. And so if you're taking this course, you probably have got some type of knowledge base about some basic brain development, but we're going to review those and hopefully pick up some new information as well. So the first thing we need to talk about is what the brain is exactly. It is a major organ of the central nervous system. It is an organ like your heart is an organ, or your liver is an organ, or your lungs are an organ. It is a major organ. It is really the major organ of our bodies. No, we could not survive without our hearts. We could not survive without our livers. But our brain is what controls those, as well as everything else in the body. So it is considered to be the most important structure in our body. We cannot live without a brain. It is responsible for monitoring and regulating much or all of the information coming from our external and our internal environments. So that means it helps us to make decisions about what we're exposed to, but also about what we say and put out into the environment as well. Some basic terms here. One is neurons, and the neuron basically is the just very basic brain cell, and we have lots and lots and lots of neurons at birth, and we have lots and lots and lots of neurons as adults. So these neurons make connections with each other, and these connections are called synapses. And so we have trillions and trillions of synapses in our brains, just a couple of years after birth. So there are tons and tons of these going on. So there's so many of these going on, in fact, that in order for our brain to run more efficiently, or most efficiently, at a certain age, at around 8, 9, 10, 11 years old, a lot of these synapses are going to end up being pruned off, because the body wants itself to run efficiently, to use the energy that it has or is given in order to be more productive. So if you think about in the spring, pruning a tree after the spring is over, a dogwood tree, you might prune a dogwood tree and cut off old things and the branches that aren't looking as good, so that next season the tree will actually be more productive and more beautiful than it was before. So basically pruning is just getting rid of the stuff that is not being used as much, or not being used as well. Plasticity is interesting here, because what plasticity is just the idea, the real idea, the true idea, that our brains are very plastic. Okay, so what I mean by that is our brains are not actually made of plastic, of course, but that they are malleable, and we can bounce back. People do bounce back from brain injuries because our brain, in a lot of ways, is able to compensate for things that it has missed for whatever reason. Okay, so those are some basic terms about the brain. The last one on the list here is called myelin. Okay, so myelin is a cover made out of fats and proteins that wraps around the nerve cell. So what it does is that it insulates neurons, these brain cells, so that they can send signals faster and more efficiently. It's white, and it is henceforth called the white matter of the brain. So if you were to look at a real human brain and you saw that it was white, it would be because of the myelin in it. So when babies are born, a lot of the nerves in their brain don't have very mature myelin sheaths, and so as a result, the baby's movements are often very jerky and uncoordinated and awkward. If you have a new baby, you've held any baby before, they are kind of jerky. They're very cute and very sweet and very cuddly, but they don't move very smoothly, and that's partly physical, but a lot of it has to do with the myelin or the lack of myelin in their brain. So as the myelin develops, movements become smoother and more purposeful and more coordinated. There are certain conditions that people can have later on where the myelin doesn't develop or it starts to deteriorate, and that's not a good thing. We won't really talk a whole lot about that, for the purposes of this class, but it's something that it's kind of interesting. You might want to look up and learn a little bit more about. All right, so psychology. Okay, so with the difference between psychology and neuroscience. So psychology is the scientific study of behavior and mental processes. All right, it is actually the study of why we act the way we do, what in our head is making us do that, what type of processes are going on. Neuroscience looks at the biological and chemical processes that make the brain and nervous system work. So psychology is kind of the more, psychology is more of the kind of the conceptual stuff, and the neuroscience is the physical, what's going on physically behind it. And the two of them work together. So this is a diagram of a cross-section of a brain, and I do not expect you to know all of those big words in there. I really don't even expect you to, in the long term, remember even some of this short list of words I have over on the left. My point in even bringing this up is just to reinforce for y'all, and honestly for me too, that the brain is really a fantastic organ and is capable of so much, and different parts of the brain do control different things. So just so you have a foundation for this as we talk through this, the hippocampus is the center to learning and memory. Okay, if we're going to remember something, if you're going to remember anything from what we're talking about right now, it's going to be because your hippocampus in your brain is working, it's functioning. The corpus callosum is the part in the kind of the middle of your brain that's responsible for communication between the right hemisphere and the left hemisphere of your brain. If that is not well developed, the right hemisphere and the left hemisphere of your brain are not going to be able to communicate well with each other or at all with each other. The cerebellum helps to coordinate motor behavior and executive functioning skills. The prefrontal cortex is critical to behavior, cognition, and emotional regulation. So you want, in the kids in your classroom, you want people in your life to have a pretty mature prefrontal cortex, and really cerebellum also, because that they probably will be easier people to get along with, because they can regulate themselves emotionally well, and they can reason and do things like that. So the amygdala is really interesting, and this is kind of what I've been reading about a lot recently, but it sits at the center of the brain's network for processing emotions, and it is responsible for the fight or flight response. If you've never heard of the fight or flight response, what that is that it's an evolutionary term. Whether or not you believe in evolution, it's really an interesting concept here, and that is that we are programmed when we are put in a threatening situation to either flee, to get away from it, to flight, or to fight it, to stand and our guards go up and we really start to face our fears there. So that's called the fight or flight. It's called fight or flight, and the amygdala is responsible for that. Now, what's interesting about the amygdala is that it prioritizes speed over accuracy, and so it sends out a lot of false signals, a lot of signals that are not necessarily what we need at that time. So, for instance, if I was out walking in the woods and I saw a curvy stick on the ground, I would automatically jump, run across the path. My heart would be racing. I would be breathing really hard. I would be panicking. I would be thinking, there's a snake, there's a snake. Now, within a second, my rational brain would see that, say, that is not a snake, that is a stick. You're being crazy for running away from a stick. But because my amygdala has kicked in quicker than what my brain is able to think, the rest of my brain is able to think, that means my amygdala is at work. That's that fight or flight response. I'm either going to fight that snake and kill it, or I'm going to get away from it. Okay, that's that amygdala doing what it needs to do. And it can be a good thing. Doing that can be a good thing, or it can be a bad thing, because sometimes we're put in situations where things are not really as complex or as dangerous as we think they're going to be, but sometimes we are, and if we are, we need to be able to respond and take care of things. So anyway, these are all things that I want you to just kind of have a basic understanding of as we're talking about young children and how they're developing, because it all kind of makes sense. So, how is the brain studied? Okay, well, it's not super easy to study the brain, in fact. It's taken, centuries to really get a decent understanding of it. Sometimes we can understand things about the brain or learn things about the brain because of accidents, okay? Sometimes people will get hit in the head really, really, really hard, and because of their injury, we learn about the brain. There is a guy that I know who was attacked several years ago, and before the attack, he was a pretty mild-mannered, cool and laid-back man. But after the attack, after they determined he was going to thankfully live, because that was actually in question because the attack was so bad, his personality did change. He did suffer some brain damage in the part of the brain that is responsible for personality. He had some anger management issues, and it was a result of the physical damaging of the brain. The most famous case of this happened in the mid-1800s to a guy named Phineas Gage. He was working on a railroad when an iron pole shot through his head, but he actually survived the accident. However, his personality and behavior changed very drastically after the catastrophe. He went, like this guy I knew, went from being very kind of cool, mild-mannered guy to being very violent and angry and unpredictable. Okay, this incident is what first led scientists to believe that various parts of the brain control different parts of who we are. Okay, and that's why, like on the previous page here, we're talking about different parts of the brain and how they affect who we are as a person. All right, lesions. That's another way we can study the brain. So people do from time to time have tumors or cancer or whatever, and have to have some type of surgery for some type of different reason. And in that surgery, there's going to involve many times some type of cutting and getting the cancer out, which means other parts of the brain sometimes are going to be cut a little bit in order to get clear lines. So by removing parts of the brain, we're able to learn what different parts of the brain do. For example, if a doctor removed a tumor in your left temporal lobe of the brain and you were unable to speak, we could assume that speech comes from that area of the brain. They were commonly actually used in the mid-1900s to control mentally unstable patients. So part of the frontal lobe in these mentally unstable patients was removed, and drastic behavioral changes occurred after the surgery. We learned from this that our personalities are strongly centered in the front of our brains. We also have different types of brain imaging, EEGs, MRIs, PET scans, CAT scans. We're not going to talk a whole lot about those, but those are all ways that doctors can do some type of imaging on your brain to see what is going on. What we have here on this slide is a little girl who's having an EEG, where those little probes all over her head are making little lines to show activity and that's going on in different parts of the brain. And this is kind of cool to look at here, actually. You can see when she's under deep anesthesia at the very bottom, there's very, very, very little brain activity. But when, she could be having a seizure. There's going to be a lot of brain activity, and it's going to be getting, from smaller to greater. So doctors can look at this type of imaging and understand better what is going on in the person's brain. Also, we've got research, which includes things like observation, assessment, experimentation, a lot of these through longitudinal studies. So researchers will, over the course of time, look at certain people and look at, how they perceive things or how they act at a certain point in their lives, and then look at it again, 10 or 15 years later, and what has happened, and they're studying the brain and personality and a lot of that neuroscience just by looking at things over longer periods of time. And this is going to involve observation, assessment, and experimentation. They may try different things to see how people act differently, and that's the experimentation part of this. So why should we actually study the brain? It is essential to the way that people behave, think, and feel. Okay? It is the essence of who we are, really. The brain is responsible for running our bodies. We cannot function without our brain. So also, when we understand the brain and how it functions, we are better able to provide kids with opportunities to grow in developmentally appropriate ways. And that is our big goal for this particular class, is and our hopes are for you to have a better understanding of how the brain works, so you can have a better understanding of why your children may be acting the way that they're acting. Also, we want you to be able to have a better understanding of maybe why you are acting the way you are, or why you are feeling the way you are. So when we can understand our own brain, we better understand how we act in relation to children. I was in the classroom for 5 years and had a whole host of different personalities in kids, and kids who had gone through some hard times and kids who had not gone through some hard times. And just kind of interesting to think about maybe some of those difficult experiences are why they were acting the way they were. Okay, so some things we need to know about the brain. I think I accidentally went the wrong way there. The beginning of the brain can be traced back to the period of the zygote. Very, 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 very early on in pregnancy. Very early on in pregnancy, before a woman even knows that she's pregnant most of the time, the brain has started developing. About 3 weeks after conception, a group of cells forms a flat structure called the neural plate, which becomes the brain and spinal cord. And this is when the baby is extremely, extremely tiny inside of mom's belly. Okay, so that's when the brain starts to develop. And when baby is born at 9 months or so, the baby actually has 100 billion different brain cells, 100 billion neurons in their brain, which is huge number. It's a huge number. Now, listen to these numbers just for comparison's sake. The average honeybee has 960 million neurons. We have 100 billion, okay? An octopus has 500 million neurons. We have 100 billion. Okay, we have an amazing brain. We've been giving amazing brains, and as child care professionals, we have kids put into our care, which is just a huge, huge opportunity to serve and to love and to help these brains develop. The brain, infant brain, weighs between 2/3 of a pound and 3/4 of a pound at birth. And at the child's fourth birthday, the brain will be at around 80% of the adult size. Now, at the child's fourth birthday, the child is not 80% of its physical size, okay, not height or weight, but it is at around 80% of its adult size for the brain. That is incredible. It has done a tremendous amount of growing in the first few years. So different parts of the brain do control different functions in the body, as we talked about with that guy that had that train rail stuck in his head. There are times that are optimal for certain times of development to take place, and these are called sensitive periods. Growth is still possible in the sensitive period, but it's not going to be as easy or as automatic as it was during the sensitive period. Periods when the brain is especially, sensitive periods are periods when the brain is especially geared toward developing a particular sense or ability. Okay. A critical period is different because they are disturbances. If there are disturbances during this period, this may actually alter the development in critical ways. Okay, so sensitive period. When we are looking at babies and language, it's very, very easy for people to pick up language early on in their life. From birth to 3 or 4, we go from not knowing language to being fluent in a language. Very few adults can go from speaking one language to 2 languages in 3 to 4 years. It's possible you can learn a second language later on in life, but it's very, very difficult because you're out of that sensitive period. Whereas if you're 1 or 2 or 3 or 4, it's a lot easier to pick up on that because you're still within that sensitive period. Having said that, if you have parents in your classroom who speak another language fluently, I would encourage them to speak to their babies and to their children in that second language frequently, because these kids that you're taking care of are in this sensitive period, and it is a lot easier for them to pick it up. Critical period. So back in the 1960s, there was in Europe a drug that was prescribed to pregnant women to help with morning sickness. It was called thalidomide, and it was given to women at roughly the same point in pregnancy. And then at birth, these babies were born many times without limbs, without an arm or a leg, or 2 arms and a leg, or whatever. And what happened is that this drug thalidomide was taken when those parts of the body were actually developing inside of mom. That was a critical period. There is a certain period where certain things are going to be growing and developing, and that period of arm and leg growth was disturbed by this particular drug. The drug was tested on animals, but animals are not people, and unfortunately a lot of people were affected by this. So that's the difference between a sensitive period and a critical period. The brain is unfinished at birth. There is a whole lot of growing to do. A whole lot of things have already happened before the baby is born, but there's still a whole lot of growing to do. There are very few working connections at birth in the child's brain, very few synapses. There may be some, but once baby is born, there is all types of stimulation and all types of things for the baby to learn. So synapses. This is when neurons communicate with other cells. This is the connection there. Neurons in all parts of the brain are making trillions of synapses. In the first few years, there are 700 synapses per second. That is an astounding number. That is a lot of synapses. Okay. At 3 months after birth, a baby has more than 1,000 trillion connections, synaptic connections in their brains. There are 15,000 synaptic connections for each cell at age 2 to 3, and by age 3, 80% of synaptic connections are already made. Okay, by age 3, 80% of synaptic connections are already made. Okay, so ages 4, 5, 6, very, very important ages. However, more connections are going to happen in the first 3 years than there are at any other time during this child's life. Okay, so you do have them at a very critical period where a lot of learning and growth is taking place. And I hope for the teachers that we work with that they realize this and that they capitalize on those precious, precious years and these sweet children. Okay, so connections are sometimes used regular. The connections that are used regularly become stronger and more complex. Okay, and that just makes sense. If you are working out, the muscles that you're working out with over the course of time are going to become stronger. So synaptic connections are going to become stronger the more and more they are used. So we know that early childhood experiences physically determine how the brain is wired, how these connections are taking place, how information is going to get from one part of the brain to the other part of the brain. We also know that excuse me, I'm going to unplug my phone there. We also know that it's not stopping ringing. Hold on just a second here. Excuse me about that. I thought I had unplugged my phone there. We know that early sensory experiences create new synapses in babies, and so exposure to lots of different experiences is very, very, very important. We know that repetition of experience strengthens these synapses, and not repetition always of the exact same experience, but different ways to experience the same thing. We know that the number of connections can go up or down by 25% depending on the enrichment of the environment. We want the kids that you are working with for their connections to go up by 25% because y'all have the capacity to do a really fantastic job working with these kids. A basic principle of neuroscience is that brains become better at doing whatever they do frequently. So I was telling my daughter this morning, and she is almost 13 and can certainly tie her shoe, but what I was telling her this morning when I was explaining this to her is that when she was learning how to tie her shoelaces, it was very, very difficult. It was very difficult. Okay, that connection had not, she was trying to figure out the motor skills to do it, but also there were a lot of things to remember in her brain, and it was very, very difficult for her to do this at first. But it became easier the more and more she did it. Those synaptic connections were developed over the course of time. There was a point in time up until I was in high school where I did not know how to type. Okay, when I took a typing class, it was a very slow go of it at first. It just, slow typing letter after letter after letter. And I became better at it, and I got good at it because it was something that I did regularly. So like I said, when we talked about earlier, pruning, the brain actually produces more synapses than it will use. And if those synapses are there and they're not being used, they're kind of getting in the way. So connections that are the brain naturally gets rid of or prunes away connections that are not used regularly. And by age 10, growth levels out and pruning begins. It shapes the brains of young children. Synaptic pruning occurs exactly for the same reason. Like I said earlier, pruning should occur like in pruning a bush. It's to rid the brain of wasteful connections and make it easier to strengthen the important ones. The brain is a very efficient machine, and the process of pruning is evidence of this. So here is a kind of an interesting little diagram here. I'm guessing this is actually came from some real imaging. You can see that at birth, you've got those brain cells there, but there are very few connections between the different brain cells. At 6 years old, there are a whole lot of brain cell connections, but by 14, they've been pruned away. It's not as dense when the child is 14 years old. So the brain has, at that point, gotten rid of a lot of the synapses that it just didn't need anymore. Now, a lot of times you'll hear about the nature-nurture debate, and I think that most of us agree that a person and how they turn out is based on nature and nurture. What we know now is that when a child is born, the genetic blueprint is there for learning. They have the capacity to learn unless there is, some serious disability, but proper stimulation has to occur. And we're going to get into what that means a little bit more practically in a few minutes. Basic brain development here is that the brain develops from the back to the front. The reptilian part, the very, very back part of the brain, deals with survival. Okay, this is the part that regulates automatic functions such as breathing, digestion, heart rate, sleep, hunger, instinctual behaviors, and things like that. That's part of the brain stem, that reptilian brain, that survival center. As we move up in the brain a little bit, and that's the base of the brain. As we move up a little bit, we've got the limbic system, which we might sometimes call the emotional center of the brain. And this processes emotions, memory, responses to fear, nurturing, caring, separation, anxiety, fear, rage, social bonding, and hormone control. And this is also the part of the brain that contains the amygdala, which is, remember, that part of the brain that is the fight or flight part of that brain. This developmental focus is during between ages of 3. There's a lot of this development in this part of the brain going on between birth and 3, whereas with the brain stem, that reptilian brain, that's developed very well at birth, typically. Okay, now we've got kind of in the front part of our brain, the prefrontal cortex. There are different developmental shifts here from around 5 and 6, at around 11, and around 15. This part of the brain handles logic, empathy, compassion, creativity, self-regulation, self-awareness, predicting, planning, solving, thinking ahead, things like that. This houses language skills and skills required to predict, plan, and empathize. And so you can see that the brain becomes really more and more complex with age and with development here. So we've got reptilian brain, or the reptilian brain, or the brain stem, the limbic system, and then the prefrontal cortex. So what are we to do as early child care providers? Well, one thing we need to do is we need to understand basic brain development, which is why y'all are here. And this is a little bit of a repetition from the last one. But you have a diagram here to look at. The brain develops from the back to the front, the stem of the brain to the front. It deals with survival. The limbic system is the emotional center, and it deals with memory and emotion. And the prefrontal cortex deals with executive functioning skills involved in decision making. So when we can better understand physically how the brain is developing, we can have more developmentally appropriate expectations. And when we do this, we can feel less frustration and take kids' behaviors less personally. Okay, I got a lot of this information out of a book written by researchers, actually to parents, on brain development. And so these authors refer to parents more than teachers, but I think it goes into both categories here. When we can understand what's happening, we can better deal with the kids. So we all have ideas about what's appropriate based on the beliefs of our family, society, and culture in which we live. When we send our children messages about who we think they are and how society views them through our language and interactions here. Okay, so we need to understand it. Okay, another thing that we can do in order to help with brain development is to really talk to the kids. And there's a lot of research that is showing language is so important. Talking to kids and exposing kids to language and reading to children. Some researchers believe that the number of words that an infant hears each day is the single most important predictor of later intelligence, school success, and social competence. Okay, you know that now. If you didn't know it before, you know that now. The parents may not know it, but you know it now. Okay, so when the child is in your care, talk to them, read their cues. They may want quiet, and that is fine, but talk to them, read to them. Don't just let them lay there. Okay? Good brain development is language development. So I have a quote here in my notes. It says, just as a baby who is starved of adequate food in the first 3 years may survive, but will never grow to his or her potential height, a baby whose brain is starved of adequate language will survive, but will have enormous difficulty learning and will never be able to read at his or her intellectual capacity. Okay, so if you don't talk to a child, they'll probably survive. Okay, they'll get by. Just like a kid who is fed junk food is probably going to survive, but they're not going to thrive. And we want the kids in our care to thrive. There is, we had some researchers, let me see, I've got the book right here, that discuss something called the 30 million word gap. Okay, so these researchers looked and did a lot of research on these kids and recording the kids and recording what these kids heard over the first 3 years after birth. And what they found was at the end of 3 years, professional families, that were more educated and that were more white collar in their jobs, these kids heard about 45 million words over the course of 3 years. Now, they're not necessarily 35 million different words, but hearing 35 million words or 45 million words over the course of 3 years. But children who came from welfare families heard 13 million words. That is huge. That is roughly a 30 million word gap, and this is pretty constant across the board. There's also different types of talk here. We've got business talk and we've got extra talk. Okay, business talk is like telling the kid what to do. Don't do that. Stop that. Quit that. Do that. Extra talk is that talk like describing, like, oh my goodness, look at your pretty, look at the pretty flower, or you're wearing a red shirt, or what are you saying? I don't understand you. Just that extra talk, that conversational talk. That is what is giving people the edge. These kids with the 30 million extra words, the edge is they're getting a lot of extra talk. We cannot control what the kids are hearing at home, okay? But when they are in our care, we can give them a stimulating environment, okay? We can give them a stimulating environment. Ways to do this: admire them, okay? This is this extra talk. Admire them. Describe to them what you're doing. Label their feelings. Read, okay? Admire them. Say, look how you're growing. You're growing so big and tall. Or describe to them what you're doing. I'm going to have to lay you down and change your diaper. Do you like having your diaper changed? I'm taking your diaper off. I'm putting a new diaper on. Or I'm about to pick you up. Are you ready to be picked up? Okay, this is a lot of that extra talk that most of us instinctively give children when we're talking to them, particularly babies, labeling their feelings. If baby's crying, saying, oh my goodness, you seem so mad, or are you so hungry, or, I see that you're laughing, or is everything just so funny? Label these feelings, label these emotions for them, and then read to them. Read to them. They need to hear those words. But what's interesting is that when they're really, really, really little, it really doesn't matter what the words are. When they're newborns, read them the newspaper, read them the magazines, read them the novel you're reading. If you're a parent in the classroom, read to them the books that you have in the classroom. They are not understanding the words, but they love the cadence, they love the rhythm, they love the snuggling. This is all very, very important to them. We need to tune in and be attentive to what the baby is interested in. Okay, like I said earlier, talk to them, but if the baby is giving you signs that he or she doesn't want to talk, then you need to lay off the talking a little bit. Be in tune to what they want. This is going to involve the caretakers making a conscious effort to notice what the baby or child is focused on when they're talking to the child. You may think you're going to be focusing on this book when reading this book, when really the child just wants to chew on the book. So be in tune to that. You may want to talk about rocks or out on the playground, but the child is much more interested in following the bumblebee or the ant around on the log or something like that. Tune into what they're interested in, even if at that point in time it's not really what you want to do. And here at the university we talk a lot about emergent curriculum, which is really interesting, and that is kind of developing curriculum as we go along based on what the kids are showing interest on in the classroom. So instead of at the beginning of every single October having a leaf unit, listening to the kids and thinking, what are they interested in right now? So it could be the beginning of October and everyone else in the entire country is doing a unit on leaves, but your classroom might be doing a unit on spiders or on fruit or something like that, because that is what the kids are interested in. So you as a teacher look at what they're interested in and follow follow that, because research shows that if there's no interest, then words have little or no effect on the child's brain development. Excuse me. I think I just turned the screen off accidentally. Not sure how I did that. But research shows that if there's no interest, then words have little or no effect on the child's brain development. The same goes on retention of vocabulary. If a child is made to participate in an activity that he doesn't have a whole lot of interest in, the child is going to be less likely to use the words to learn the words that are being used, and this just makes sense. When we're talking to the kids also, and this really probably should have gone on the previous slide, but when we're talking to the kids, we want to use this infant-directed speech, or it's also called parentese. And this is like looking in, being attentive to what the child is interested in, and then talking to them in this parent-directed speech, which is kind of a higher in pitch, slower, dragging out the words, enunciating words. This is something that most of us do instinctually. We look at a baby and we don't talk to them like we would talk to an adult. We talk to them in this kind of sometimes goofy sounding way, because that's what we know they respond to. They need to hear those words. They can hear those higher pitches better. It's used instinctively all over the entire world. By appealing to a baby's ears, it helps to draw attention to what's being said and who is saying it, encouraging the child to be attentive, to be engaged, and to interact. Okay, so just do that. Read to babies. Read to babies and children consistently and frequently. Studies have shown that babies who have been read to in the earliest years have a larger vocabulary, and really they even have better math skills when they start kindergarten. There's also evidence that a parent who shows enthusiasm for reading strengthens a child's interest in learning to read and puts the child on the road for being a more successful reader later. Okay, so reading is so good for the brain. But, okay, a lot of times babies aren't going to sit still. Babies are going to want to chew the book. Baby is going to want to flip through the book or look at the book upside down. The 2-year-old is going to read a page and then decide he's bored and get up and go do something else. This is where we have to tune in, which was on our previous slide. This is when we have to tune in and follow their lead and talk about it. Okay. We talked about this next point earlier. Babies won't understand the words initially, but they're comforted by the rhythm of speech, warm human contact. This is critical during these first few months. They need human contact. We need to create a safe environment for kids, of course. They need to know that they're taken care of. They need to know that they can trust the world to take care of their needs. Babies really do depend on adults for everything. Unfortunately, a lot of children undergo something called toxic stress, and this is stress that occurs over long periods of time. All people, even babies, are going to experience a certain amount of stress, and that's not really necessarily a bad thing. That's not a bad thing at all, but when it's extended, severe or extended, the child's brain connections are permanently and negatively impacted. Okay, we were talking about the synapses earlier. What the child gets used to is what their brain is going to do. So if the child has to scream and go through incredible stress in order to get fed or held, then that's what's going to become normal to them. That's the connection their brain's going to be making here. The result with kids who grow up with toxic stress is that they're going to grow up with more difficulty learning, controlling emotions and behaviors, and trusting others. So children also grow up more prone to even physical problems in their bodies, such as diabetes or obesity, cardiovascular disease, and autoimmune disorders. Okay, we need to provide clear responses to babies' actions. We need to let them know in a firm and kind way sometimes that they can't do something. We need to also give them freedom within boundaries. They need to know that they are able to do things. We need to give them that autonomy. They, when they're a month or 2 or 3 old, that's not going to be a huge issue. But as they get to be where they're mobile, they're going to want to get around and play and drop things, and they need to be able to experience these things. So give them freedom within boundaries. And for babies and for toddlers and for preschoolers, and I would even say elementary school kids and older. Touch, sound, sight, taste, and smell all build connections, okay? In order to really build these connections, a lot of mess really has to be made, okay? So this is going to look like with art, a lot of not beautiful looking pictures. This is going to involve, mud underneath fingernails and dirty, smelly, socks and just messy clothes and things like that. Give them the connection to get or that opportunity to get messy because they're learning. And when we let them get messy, this is going to offer a lot of opportunity to talk and to describe and to discuss things. Studies show that children who are, just incidentally, that are regularly involved in doing art do better in reading and self-regulation also. There's such a push to teach kids how to read early, and I'm just going to be here to tell you, yes, they might be able to learn some things about reading earlier, but they're not going to really appreciate how to read. They need to be experiencing and getting messy and playing with things, and these things are developing the structures in the brain so that they can do well when they get to school, so they can self-regulate, they can be more pleasant people to be around, and they actually are better at reading. We also need to express joy in the child. We need to let kids in our classrooms or in our homes know that they really are special, and we can do that by just simple things: smiling, saying their name, making eye contact with them. We need to express joy in the child both in our words and in our body language. We need to let them know that they're loved, okay? Also, I'm going to say we need to give them slightly challenging things to do. Don't always give them something that's, don't frequently give them things that are too easy for them. Give them things that are just a little bit harder, that they're capable of doing, but they have to stretch in order to do that. That's where growth happens. All right, so a principle here: babies' brains learn best through social interaction, okay? Babies' brains learn best through social interaction. So don't put them in front of the TV. Don't put them in front of the TV. It's not good for them, okay? We know that babies learn a second language a lot easier through a live person, through a real person conversing with them, than they do watching some video on TV trying to teach them a second language. What's also interesting is that if you were to look at a baby watching a video versus a baby, watching a live person on Skype, the babies who, watch the live person on Skype maybe speaking a second language are going to pick up on that language. They're going to pick up on that language, maybe not quite as efficiently as they would if the person was right there in the room with them, but they're going to pick up on that language because it is a human connection. It is real. There is real interaction much quicker than they are with a recorded something on TV. So talk to these kids. We know that infants can show a wide range of positive and negative emotions. They're not always super complex at first, but sometime during the second year, the brain has developed enough so that they can display secondary emotions such as like pride and shame and guilt, jealousy and embarrassment. We know that the genetic blueprint of a child is much like a blueprint of a house. It can be there, that background can be laid, but without proper materials, builders, workers, it's going to be there, but it's not going to function well. Okay, so we need to be sure that we are doing the right things and we have the right environments around the kids for them to really thrive. Emotions can be very hard to moderate for kids, and that's when I was talking about talking to kids, talking to young children, labeling their emotions and helping them talking about them. We have to help moderate them. This is done through soothing and distracting. We have to help them to learn how it's done. So we do this by labeling and validating them, suggesting constructive ways to deal with negative emotions. When this is done well, kids are better able to regulate emotions later in life. Okay, effects of maltreatment on brain structure. Unfortunately, we know that abuse happens, and we have child care professionals have responsibilities if we suspect there is abuse going on. But just so you can understand what some of these kids, if they have been in an abusive situation or neglectful situations, have gone through, what their brains have actually had to endure. If you'll remember back to the beginning of our presentation, you'll remember that the hippocampus is central to learning and memory. Toxic stress can reduce the hippocampus's capacity to bring cortisol levels back down to a normal level after they've occurred. So we also see that there's reduced volume in the hippocampus. Okay. We know that there's reduced volume in the corpus callosum, which is the structure that connects the right and the left hemispheres. The brain physically looks different. There is a decrease in volume in the cerebellum. All right. There is a smaller prefrontal cortex. There's overactivity in the amygdala, and there's abnormal cortisol levels, either higher or lower. Higher cortisol levels can harm cognitive processes. They can subdue immune and inflammatory reactions, and they can heighten the risk for affective disorder. So there's a lot going on physically, okay? This next slide, I think, is just fascinating because it actually shows, like I keep saying, that the brain physically looks different. These are two different images. One is a typical brain versus a typical child's brain versus one that is experienced extreme neglect. Okay, that second brain there under extreme neglect has got to be 30% smaller than that first brain, and we see that there is some type of emptiness in the middle there where that's not there so much in the first picture. And I honestly don't know what these structures are that I'm looking at, because as much as I love brain development, I'm not a brain doctor or anything like that, and I don't want to tell you anything incorrectly, but you can see that there is a startling difference in those two brains. Also a startling difference in the second picture here. We've got a healthy brain versus a brain of an abused person. And you can see again that the brains look startlingly different, okay? In that second picture here in the abused brain, there's missing parts in the part of the brain that focus on higher mental functions such as concentration, planning, judgment, emotional expression, creativity, and inhibition. So this is not just some, this is, what we're talking about is not just some, highly intellectual stuff that people are thinking may or may not be going on. We know just by looking at the brain that there are physical things that are going on. So the reason I even really want to bring attention to you is that if you've got kids in your class who have gone through toxic stress, who have experienced extreme neglect or abuse, their brains actually may not be able to function. They actually may not be able to function the way that a typical brain is. So these kids may actually not be able to inhibit some of their impulses because that part of their brain is actually missing or much smaller. I want people to know that a lot of times what we label as misbehavior in classrooms, I did the same thing, may not be because of bad parenting, and it may not be because the kid really wants to misbehave. It actually could be that there is something missing in the brain or something smaller in the brain than it should be. Just to give you a little bit of sympathy and understanding. We've got to have understanding with these kids. We do know that the brain is very plastic. The plasticity, like we said earlier, is the capacity of the brain to change with learning. It includes the brain's capacity to be shaped or molded by experiences, the capacity to learn and remember, and ability to recognize and recover after injury. I hear about people all the time who have had a stroke or a brain injury and they have recovered. The brain is plastic. It can, under the correct circumstances, recover to some degree. The entire brain can change to better cope with the environment, which is really, really cool that our brain can actually cope to deal with the environment that we're in. And the environment plays a key role in influencing plasticity. If the child is in an encouraging environment, a loving environment, a kind environment, the brain is going to be able to adapt better. So to remember here, a couple things to remember, and that there are many ways to obtain good outcomes in the brain. There is no one formula that the kids that's going to develop a good kid. It's going to be different in different people because of brain chemistry and environment and everything. Okay, there are many ways to obtain good outcomes in a kid. Self-development unfolds uniquely for each child. Every child's development is going to be different. I've got 3 daughters, 12, 10, and 8, and they are all growing in different ways. So I can see that even in my own home. And self-regulation and socially acceptable behaviors take time to develop. So you may see difficult behaviors in your classroom. You may see biters in your classroom, kids that bite all the time or are always hitting or throwing. Okay, these things you don't want to encourage, but you need to know that they are typical, they're normal, and those parts of the brain just haven't fully developed right now. One last thought I want to read to you, that this is interesting. I have a quote I just wanted to read you. It says, this compensating ability is great news. Children are naturally flexible in how they grow and learn, so are their brains. They arrive pre-wired with multiple opportunities for development. They're endowed with the ability to take advantage of many things in many ways. They also have large capacities to self-correct and rebound from problems, upsets, and with a margin of error to absorb the bad. Infants need leeway in learning to be persons, and parents need leeway in learning to parent. And the adaptability of infants, Mother Nature has given us both. Okay? So these kids are amazing, and y'all are amazing for working with them. And just remember that they are capable of so much, and you are capable of giving them the opportunity. My very last slide here, just real quickly, is some of the sources that I got some of this information from. If you want more information about this, I'm happy to give it to you. So give me an email at kbrothers@ches.ua.edu if you've got any questions. That's kbrothers@ches.ua.edu, and my phone number is 205-348-0682. Thanks so much for your time, and just continue on with the course now.